metric system, notice I have these letters K, H, DA, U, D, C, and M. These letters are the first letter of our metric prefixes. U is what we're going to use to denote our unit, whether it be meter, liter, or gram. Now the metric system uses three basic units of measure. Again, the meter, liter, and the gram. Length in the metric system is used by measuring meters. So metric system measures length using the meter. The symbol for meter is M. 1 meter is a bit more than a yard. The basic unit for capacity in the metric system is called the liter, which is a little bit more than a quart. And the basic unit for measuring weight in the metric system is the gram. This is a very small unit. A nickel weighs about 5 grams, so it's even less than the weight of a nickel. Metric prefixes. These are what I was talking about above, where we had the first letter of each of them. All units other than the three basic units, which are meter, liter, and gram, are based on multiples of the basic units, with those multiples all being powers of 10. So our first metric prefix is kilo, where we were using the letter K. Now I use a capital K and a capital H and a capital D, and that's just helpful in me remembering which values are larger and which ones are smaller. But technically it's just KHDA, and they're all lowercase. So our first one is kilo. Our next one is hecto, which is our H. Then we have deca, which is our DA. Then we have our unit, which we were using U. After that, we have deci, centi, milli. Now it says up here that all of the multiples are powers of 10. So if our basic unit is just 1, so let's say we're talking about meters, so we have 1 meter. A decameter would be the same as 10 meters, or 10 to the power 1. That's why it says units. So 1 meter. If I wanted to use a meter to measure a decameter, I would need 10 of them. If I wanted to use meters to measure a hectometer, I would need 100 of them, or 10 to power 2. And if I wanted to measure a kilometer using meters, I would need 1,000 of them, or 10 to power 3. So a kilometer is obviously very, very large, as it's the same as 1,000 of our meters, which we saw earlier. It's just a little bit longer than a yard. So imagine if you had 1,000 yards. Even bigger than that would be a kilometer, or an even longer length would be a kilometer. Now let's look at the ones that are smaller. So if I wanted to measure a decimeter, I would only need the same length as 1/10 of our meter, or 10 to power -1. And if I wanted to measure a centimeter, I would need only 1/100th of a meter, or 10 to power -2. And lastly, if I wanted to measure a millimeter, it's the same as 1/1000th of the length of a meter, or 10 to power -3. When you have this negative exponent in the numerator, it drops the base and the exponent to the denominator, and the exponent becomes positive. So a meter versus a decameter, let's just look at some lengths. Let's pretend that this length here, this little ruler, is a meter. How many of these meters would we need to measure the distance of a decameter? Well, up here we see that we would need 10 meters. So we would need 10 of them. So I want us to draw an illustration. So it's not going to be great because we're going to draw it ourselves. But if I need 10 of them, then I'm going to try to draw 10 of these same length little rulers. I'm just going to draw a rectangle. So there's 1, 2, 3, and go on until you have 10. this length here, which is 10 of these meters, is the exact same length as 1 decameter. So notice this length is the same. Well, that looks nice. Anyways, okay. So this 1 unit of this length is 1 decameter, while I needed 10 meters to measure that same distance. Similar to how we would need 5,280 feet to measure the same distance as 1 mile. The metric system is nice because it's based off these powers of 10. If you remember from other sections, if we multiply by 10 or divide by 10, we're really just moving our decimal point either to the left or to the right. So converting between these units is very simple because we can just move our decimal point however many places we need, either to the left or to the right. So back here with this illustration, we notice that these 10 meters represent the same length or distance as 1 decameter. So 10 meters is 1 decameter. Or in other words, it takes 10 meters to measure the same distance as 1 decameter. Alternatively, we can think of 1 meter as 1/10 of a decameter, right? So if I just went down and I measured this same distance or length as this blue rectangle on this red rectangle, it's 1/10 of the red rectangle. Conversions in the metric system. To change a larger unit to a smaller unit in the metric system, multiply by 10 to the power n, where n is the number of steps that you moved down in the previous table, so the table that we had earlier, right here. Move the decimal point to the right. The number will get larger because you need more of the smaller units to cover the same distance as the larger units. Same thing we had up here. We needed more of the meters to cover the same distance as 1 decameter. To change a smaller unit to a larger unit in the metric system, divide by 10 to power n, where n is the number of steps that you move up in the table. Or in other words, now you're going to move the decimal point to the left. And we'll see this in a little bit. In this case, the number will get smaller because you need less of the larger units to cover the same distance as the smaller units. Again, we only needed 1 decameter, which is a larger unit, to cover the same distance as these 10 meters covered. So there's kind of a shortcut that you can do to convert between these units. So all you need to do is to look at this chart that we had at the beginning. If you count steps to the left, you'll move your decimal point to the left. And if you're counting steps to the right, you're moving your decimal point to the right. When you move your decimal point to the left, so when I move this way, let's say we had the number 1,000. If I take this decimal point and I move it to the left, the number gets smaller. It becomes 1. This is the same as dividing by a power of 10. So, right, if I'm dividing by this positive power of 10, I'm going to end up with a smaller number. But if I take that value and instead I move my decimal point to the right, my decimal point's here and I move it this way. Let's say I move it to here. I've now added some zeros and my number gets larger. And this is the same as multiplying by a power of positive 10. I'm sorry, a power of 10 to a positive exponent. So my numbers are going to get larger. To remember this phrase, this KHDAUDCM, you can use a memory phrase. There's a few different versions of this, but the one that I know is King Henry doesn't usually drink chocolate milk. So when you're taking your exams or quizzes and you need to do the metric system, you need to know this order. So if you say to yourself, King Henry doesn't usually drink chocolate milk, it'll give you all of the letters you need and in the order you need them. Let's use this shortcut trick of just moving by counting the letters in this phrase to convert some of these values. Let's start with 43 kilometers to meters. Okay, so I always write down my chart. So I have King Henry doesn't usually drink chocolate milk. And I always write the A there because there's technically two D's. And when you see your values, like look at part C, DAM and DM, they don't use capital letters like I do. I use capital letters just to indicate that these are like bigger or longer lengths or larger values, and I use the lowercase letters to indicate that they're smaller. But in reality, when you're reading them, they're not going to be capitalized. So you need to know the difference between DAM and DM, or DAG and DG, which would be from this one to this one. Okay, but back in part A, I'm trying to go from kilometers to meters. So what you do is you go from where you're starting, which is K, and you count your way back to meters, which for us is our unit. So I'm going to count 1, 2, 3. Or I need to move my decimal point 3 times to the right. So take your value of 43, find your decimal point. If you don't see it, that means it's at the end on the right. And you're going to count 1, 2, 3, and you're going to put it where you ended. And then fill in all of those gaps with zeros. So what we see is that 43 kilometers measures the same distance as 43,000 meters. Or what we really did was we multiplied 43 by 10 to the power 3, which makes sense if we go back to our table. It takes 1,000 meters to measure 1 kilometer, right? Because 1 unit, it would take 1,000 of those units. So I need to multiply by 1,000, or 10 to the power 3. If you want, you can pause the video and try parts B and C on your own, and then come back and check your work. So again, every time I do these problems, I write down the phrase or the order of our prefixes. Now I'm going from milligrams to grams. Remember, our unit can change. The unit's either going to be meters or liters or grams. In this case, if you see a G, it means grams. When you have this M, it's meters. And if I had one with an L, it would be liters. So I'm starting at milligrams, which is this small m, and I want to count back to gram, which is my unit. So I'm going to count 1, 2, 3. So now I'm doing 3 to the left. So I take my value, which is this 1200.3. I go to my decimal point and I move it 1, 2, 3, and it's going to end up between the 1 and the 2. So I have that 1200.3 milligrams is the same as 1.2003 grams. Now, since milligrams are smaller, it makes sense that you need a lot more of them to measure the same weight as just 1.2003 grams, right? A gram is larger than a milligram, so it's going to take more milligrams to measure the same weight as those grams. In part C, again, I'll write down my prefixes. I'm going from decameter to decimeter, so from DA to D. That means I'm going to move twice, take my decimal point, which I can't see, which means it's at the end on the right, move it over twice, fill in any empty gaps with zeros, and we see that 57 decameters is the same as 5,700 decimeters. Again, it takes a lot more of a smaller unit to measure the same distance as a larger unit. All right, some English and metric unit conversions. So 1 inch is the same as 2.54 centimeters. 1 foot is the same as 30.48 centimeters, which is the same as 0.3048 meters. 1 yard is the same as 91.44 centimeters or 0.9144 meters. And then a bunch of the other ones are approximate, so a mile is approximately 1.61 kilometers, and so on. So we're going to utilize this chart of English and metric units to convert some more in problem 8. So part A, let's convert 142 feet into centimeters. Well, looking at our conversions over here on the right, I see that we have a conversion that goes directly from feet to centimeters, and it's right here. So we can utilize that as a unit fraction. Starting with what you were given, which is 142 feet, you want to multiply by a unit fraction that will simplify the feet. So I need feet to be in the bottom, and I want to go to centimeters. So that means I have 1 foot on the bottom, which is the same as 30.48 centimeters. Feet simplify, and what we're left with is 142 times 30.48, and the units we have are centimeters. And plugging that into your calculator, you get that 142 feet is the same as 4,328.16 centimeters. Let's try part B together. This one we're doing decimeters to yards. And if I look over at my conversion chart, I don't have anything that goes from decimeters to yards, but I do have something relating yards to centimeters. Right here I have 1 yard is the same as 91.44 centimeters. So if I could start by converting decimeters to centimeters, then I could utilize this as a unit fraction. Well, we know how to go from decimeters to centimeters. Using our prefixes. So decimeter is the D and centimeter is C, so I just need to move that decimal point 1 time to the right. So if I move that over once and fill that in with the 0, I get that 47 decimeters is the same as 470 centimeters. So now I can utilize this to say 47 decimeters is the same as 470 centimeters, which I can multiply by a unit fraction using the information over here. I want centimeters to cancel out, so I'm going to put that in the denominator, and I'll put yards in the numerator. Centimeters will cancel. What I'm left with is 470 divided by 91.44, and the unit I have left is yard. And plugging this into your calculator, you get that this is approximately 5.14 yards. Why don't you take a second and pause the video and try part C on your own, then come back and check your work. So similar to part B, we don't have anything that directly goes from millimeters to feet. I do have millimeters to inches, which I could then do to feet, or I have something where I have feet and centimeters, so maybe I can use the same exact thing I did in part B to first convert millimeters to centimeters and then use this conversion here using feet. So again, let's use our prefixes. And I'm going from millimeters to centimeters. So I just need to go back once. So I really just need to move this in between the 1 and the 3. So 213.36 millimeters is the same as 21.336 centimeters. So now using this centimeter value, I can multiply this by 1 foot over 30.48 centimeters. Centimeters will cancel. I'll be left with feet. I need to divide these two values to get 0.7 feet. And like I said, you could have also utilized the conversion here where it goes from millimeters to inches. So if that's what you tried, I'll do it down here. I could keep this 213.36 millimeters, and I'm going to use a conversion or a unit fraction using this one. So that says in 1 millimeter, it's approximately 0.03937 inches. And then I also know how many inches are in a foot, which is 12 inches for 1 foot. My millimeters will cancel, my inches will cancel. I'm still left with feet, which is exactly what I wanted. The math I have, though, is 213.36 times 0.03937 divided by 12, because I have that 12 in the denominator. And if you plug this into your calculator, you're going to get 0.6 with a bunch of nines, which is approximately 0.7 feet. So even though it's not exactly the same answer we got at first, if you round, it is basically the exact same answer. It's so close, right? And the reason that it's different is because of this approximation here. So 1 millimeter is approximately 0.03937 inches, not exactly. Versus up here, when we were doing feet to centimeters, this one was exact. So there was already a little bit of our rounding error, which is why our answers were not exactly the same until I rounded them again. And even in that case, it might not be exactly the same when you round, but it should be very, very, very close.